Hi, this is Ian Magaha, and we are taking a look at problem set number 5, problem number 3. And in this problem, we're really filling out the class cipher text message. So we have a couple of methods, literally just a couple. I believe that we only have two. Yep. We're going to have the initializing method right here. It's just going to initialize a cipher text message object. And the text right here is going to be a string that is obviously the message's text. And our text message is going to have two attributes. It's going to have message text and valid words, but it's a subclass of message, and the parent class message already has the attributes of message text and valid words. So we can literally just use the method for initializing, or the parent class constructor, excuse me, the constructor. We can use a messages constructor that just takes in self and a text, so we can fill out message text. And then our second method is going to be decrypt message. So and this is just going to take in self. So we're going to decrypt self.message text by trying every possible shift value and finding the quote-unquote best one. Obviously, we're defining the best as the shift that creates the maximum number of real words when we use apply shift. If the shift is the original shift value used to encrypt the message, then we just expect 26 minus the shift to be the best shift value for decrypting it. If we like, this makes sense because encrypting, you're essentially taking the spot of the message, or the spot of the character, excuse me, and adding shift to it. So how do we reverse this? Well, we take the spot and we subtract shift from it. So, and then if multiple shifts are equally good, that they all create the maximum number, you may choose any of those shifts. So it doesn't matter. We're keeping it simple. And we just, the decrypted message, we just can return any of them. And what we're returning is a tuple of the best shift value used to decrypt the message and the decrypted message text using the shift value. So we're gonna have two different variables we initialize initially. That's going to be true shift. This is what we're actually going to be returning. This is the tuple. Actually, I think I should actually change this to none, not 0. There we go. So that's the true shift that it actually is that will be returning, and then the max words. This is the actual maximum amount of words that we found in using the shift values. So the way that we're going to find the correct shift is that we are going to test each shift number. So 0 through 25. We're going to test all 0 through 25 shifts, and whichever one produces the most amount of words, that's our correct one. So we're going to use the variable words. This is going to be our test case. We're testing for each shift value what the maximum amount of words we can create are. So, and then we're also going to have our possible message. Our possible message is going to be the message that is created after applying the shift with the current shift that we're testing. So possible message isn't actually going to be a string. It's actually going to be a list, because we are applying shift. We're using the apply shift method, taking in our current shift that we're testing in the for loop, and then we're splitting it. So we're splitting each individual word into its own entry in a list. And then for each string in possible message, we want to check to see if it's a word, and we do this by using the valid words method right here. This, I feel like, should be... Was that working without... Huh. No. That should be it, right? Because valid words is just the list of correct words. It's not actually the function. Sorry. So we're going to test if each string is actually a word, and that's with the isWord method, or function, isWord function. And then we're going to input the valid word list, which is what this is. I almost messed that up. So it's the object's valid word list, and then we're also inputting string, which is the word that we're testing. So if this ends up being true, if the word is actually a word, then add 1 to the words. If words is greater than our current max words, then true shift is going to be equal to what shift we were testing in the for loop, and max words is going to be equal to however many words that we were able to produce with this current shift value. And then after we loop through and we find the shift value that produces the maximum amount of words, we're going to return the tuple that includes the correct shift value, and we're going to also return the decrypted message. So we're going to do the objects method apply shift, and we're taking in that true shift. So, and I believe that is all for the class. So let's go ahead and test it. So we're going to have print, we are testing the problem 3, and let's create a ciphertext message. So we're going to C is equal to, cipher starts with an, or cipher is spelled with an I, not a Y. So we're going to go cipher text message right there. And then I believe, what does this take in? Let's see. Text. Okay. What should we make the text? Let's, oh, you know what? Let's do, what did we get from problem 2 when we were testing with Apple? DSSOH. DSSOH. There we go. And let me put this in quotations. There we go. Okay. And let's go ahead and test decrypt message. So C, we're going to print C dot encrypt. Or decrypt. Is it decrypt? Yeah, decrypt message. There we go. Let's run it. Testing the problem 3. We are going to see that our true shift value is 23, and our correct word is apple, which in problem 2, we saw that when we shifted by 3 with a original text message of apple, we got DSSOH. So when we create a ciphertext message with a DSSOH, we see that to shift it back, it's 23. And if you remember earlier when we were talking about the decrypting function, or this decrypting method, it is 26 minus the original shift value. So 26 minus 3 is 23. And then obviously our decrypted word is apple. So that functions and works how we expected it to. I will see you in just 1 second to look at problem number 4.